section 4.5. Limits at infinity. We use exactly the same rules for the limits, but now our limit is approaches to the infinity. Before we start that, if you remember that f of x as a function, f of x equal x over x plus 3x minus 1. X plus 3, x minus 1 are the asymptotes. X equal negative 3, x equal 1. So we have to take the denominator equal to 0 and solve it. So we're going to get x equal negative 3 and x equal 1. These are two asymptotes and non-removable discontinuous. Because you can't remove the asymptote. But the function is going to be discontinuous. Here's another example. If we have f of x equal x plus 1, x plus 3, and x plus 1. Check here. You can cancel these two parentheses. That means x plus 1 or x equal negative 1 are removable discontinuous. When you graph this function, you're going to see there is a hole when x equal negative. That's why it's still discontinuous. This one is removable discontinuous, not an asymptote. Let's go if we have a limit approached to the infinity or negative infinity. Check, this is our basic. Always we're going to depend about solving our find the limit based on these two limits. Limit x approach to the infinity 1 over x. 1 over x. So let's check here. I did the table. If check the x approach to the infinity, 1, 10,000, and keep going to the infinity. Check the y value is approach to the 0. So when you graph this function, you'll see the function when x going to the infinity, the function going down approach to the 0. For the negative infinity, that's mean going to this side, x going to the negative infinity, the same thing, the function going to the 0. So it's basically look like this, the graph. Here's the positive infinity. Every time when you go into the infinity, the function is going down. From the other side to the negative infinity, the function is going down. And we already know the 0 is an asymptote. That's why we have two paths, because there's an asymptote here. So this is our basic function. You will see when we do an example, we're going to base on these. If f of x gets really close to a certain number, as x approach to the positive infinity or negative infinity, that means the limit exists. There's a limit. There's another, based on these, if we have exponents, that's mean 1 over x to the power n, and always the limit approach to the 0, you can say, okay, it's the limit, and here's the exponents. That means the limit exponent times n times. The same thing is going to be. This one, the limit 1 over x, x approach to the 0, always 0. So 0 to the n equals 0. The same thing if we have negative infinity, 1 over n, the next one is going to be in here. That means 0 to the n equals 0. So if you look here, always is our basic. We want to use this one as a basic function when we try to solve and find the limit as x approaches to the infinity. Here's another one. The limit of polynomial as x approaches to the positive infinity or negative infinity. Like this is exactly like an example. The limit when x approaches to the infinity, x cubed. We already know the graph of x cubed is the graph of x cubed. As a basic function or parent function. So as x approaches to the infinity, that means we're going to work on this side. When x approaches to the infinity, check the limit goes where? Goes to the positive infinity. That means the result is going to be positive infinity. This one also as a basic function, you already know how is the graph of x cubed, x squared, square root of x. So you have to know the graphs of these basic functions. Y equal x cubed, y equal x squared, y equal square root of x, y equal absolute value of x, y equal x. You have to know the graph of these basic functions, but also we already know the graph of 1 over x. If you know the graph of these basic function, you're already going to imagine how is going to be the limit. So the limit for x approach to the infinity for x cubed on this side is going to the infinity. What about if x approach to the negative infinity? That means the other side here is negative infinity. You see the graph is going down, so it's going to be negative infinity. Here is the graph of x squared. The graph of x squared. If you look to the limit, when x approach to the infinity, that means the positive side, the y coordinate going where? Going to the infinity. So it's going to be positive infinity. The limit when x approach to the negative infinity is going to be also positive infinity because the graph of x squared, both sides going up. So my advice, you have to know the graph of these basic functions. And there's another one, y equal the cubic root of x. So what they're saying here, limits of polynomial always follow the behavior of the highest exponents. If you have polynomial and you're trying to find the limit, always look where is the highest exponent. For this example, limit when x approach to the negative infinity, this is polynomial. I'm not gonna look to all the paths, only for this one because this is the highest exponents. That means I'm gonna look for the limit negative 3x cubed. If you look to this graph, the graph of x cubed, this side is up, this side is down. This is the graph of x cubed. But there is negative sign here, and there's a number here. I'm not gonna focus on the number. The negative sign here is going to reflect the graph over x coordinate. That means this side is going down, and this side is going up. So this is the graph of negative x cubed. The 3 is going to be stretch the graph vertically. We're not going to focus about that because we're trying just to find the limit. That's mean when x approach to the negative infinity, which is this side, the limit is going where? The infinity. Okay. So always when you have polynomial, go ahead, focus on the highest exponents. For the first example, I say, okay, how am I going to solve this one? I need to find the limit when x approach to the infinity. It's not x approach to the certain number, so you can plug in the number and you can guess. No, it's x going to the infinity. Always when you see example like this one, like a rational, and there's polynomial on the top, polynomial on the bottom, you can say, okay, what I'm going to do, write down this as a note. Always you're going to divide, everything by the highest power here on the denominator. What's the highest power here? X to the power 1. So the highest exponent is x. I'm just going to look for the whole term. That's it. I'm going to divide everything by x. If you have x squared, you're going to divide everything by x squared. So in this case, for this example, it's going to be limit as x approach to the infinity. It's going to be 5x divided by x minus 2 divided by x. Everything divided by 3x divided by x minus 9 divided by plus 9 divided by x. We already know the limit is going to go here, go here, go here, and go here. So I don't have to distribute the limit. Because I know this is 10, I can say, okay, it's the limit of this term. the limit for this term, the limit for this term. Now I need to simplify it. So this one is going to be the limit as x approaches to the infinity. Simplify this one, it's going to be 5 minus 2 over x divided by 3 plus 9 over x. I can't simplify it anymore. Now, the limit for a constant, it's constant, it's still constant. So the limit for the constant is constant. The limit for 2 over x is minus the limit for 2 over x. I already know the limit for 1 over x is 0. So this part here is look like, what are you doing? You're saying, I'm taking the limit as x approaches to the infinity, the 2 over x. Right? 2 is a constant. I can write it down here. It's 2 limit as x approaches to the infinity, 1 over x. The limit for 1 over x is 0. So it's going to be 2 times 0, and then it's going to be 0. So that's what we're doing. But I'm just going to do this one, the limit here. If you want to do it, it's fine. So you're not going to get confused. That means the limit for 5, the limit for 2 over x, the limit for 3, the limit for 9 over x. Okay, you can do that. Distribute the limit. You like distributing the limit. The limit, so this one is 0. The limit for a constant is a constant. The limit for 9 over x is exactly what we did here. Because 9 over x, 1 over x is 0. That means the limit for 9 over x is going to be 0. That means the result is going to be 5 over. So the limit when x approaches the infinity, 5x minus 2, the x plus 9 is going to be 5 over. Can we do the same thing with the next example? On next example, we don't have to do divide by x squared, because you don't have to combine these together. It's already there, like everything exists here. It's look like you're doing, okay? It's the limit when x approaches to the infinity to the 5, like distributing the limit minus the limit when x approaches the infinity 2 over x squared. I already know 1 over x is going to be 0. 1 over x squared is the same thing. So also the limit for this part is going to be 0. The limit for the constant is going to be constant. Minus 0, then the result is going to be 5. Okay? Example 3. The limit for 3 over e to the x. Before I'm finding this one, can I move e to the x to the top? I'm just gonna go ahead and write this one again. This one equal the limit as x approaches to the infinity is 3 e to the negative x. Can I take the 3 out the limit? Yes or no? Can I take the 3 here? Yes, it's one of the limits rule. So this one is going to be equal to 3 limit as x approaches to the infinity e to the negative x. If you check the graph of e to the x, the graph for this function is look like this. So when x approaches to the infinity, the limit for e to negative x approaches to where? To the 0. The y coordinate going to the 0. That's mean the limit for e to the x is going to be 0. So it's going to be 3 times 0, and the result is going to be 0. So the graph for e to the x is going to be like this. And the graph for e to the x is the other thing. You have to know the graphs for e to the negative x and e to the x. So again, let's check this one. It's exactly like the first example. Find the limit when x approaches to the infinity, 2x plus 5 over 3x squared plus 1. I'm going to check how I'm going to find the limit for this one. I'm going to divide both top and the bottom by the highest x with the highest exponent, which is x squared. So I'm going to say I'm going to divide by x squared. This case is going to be the limit when x approaches to the infinity, 2x over x squared plus 5 over x squared divided by 3 x squared divided by x squared plus 1 divided by x squared. Now, if you want to simplify it, this one is going to be the limit as x approaches to the infinity. This one is going to be 2 over x. This one is going to be 5 over x squared. Here is going to be 3 plus 1 over x squared. Now, next step, you just going to look like distributing the limit, because you can take the limit from this part, limit for the second one, limit for the third one, limit for the fourth one. So the limit for 2 over x is going to be 0. The limit for 5 over x squared also is going to be, that's it. This is constant, is going to be 3. This is going to be 0. So it's going to be 0 over 3 and going to be. Next example, we're going to do the same thing. We're going to divide everything by, careful here, divide everything by x cubed or x.
X cubed.
No, be careful, divide by here, I'm using the denominator. Take the x with the highest exponent on the denominator, okay? So be careful with this one. So by x. So it's going to be the limit of x approaches the infinity, 7x cubed divided by x minus 2 2x squared divided by x plus 1 divided by x and going to be 9 divided by x minus 2x divided by x. This is what's going to happen. So here it's going to be equal the limit for x approaches to the infinity, 7x squared minus 2x plus 1 over x over 9 over x minus 2. 9 over x minus 2. If you divide by x cubed, it's totally different. And if you try to use the table to find the limit, you will see it's going to be different answer. That's why I always want to choose divide by where is the x with the highest exponents on the bottom part. You can divide everything by this x. Now, if you look for this one, the limit for the first part is going to be 7x squared. Keep the 7 out. What's the limit for the x squared? Remember, the limit for x squared going where? From both sides, going to the infinity. What about 7x squared? Is it still going to the infinity? That means the limit for 7x squared is going to be infinity. Minus 2x. Negative 2. The limit for the x, if you graph the function x, the function x looks like this. Okay? I'm talking about the limit to the infinity. Talking about the limit to the infinity. So the limit for -2 is going out. The limit for the x for the infinity is going to where? Also to infinity. So let's say minus infinity. 1/x is going to be 0. So everything here, we can say infinity minus infinity 0, and we're going to say infinity. What about 9/x? 9/x going to the 0 minus 2. So any positive number, because this is going to infinity, is still positive. If any positive number divided by negative number is going to be negative. That means our result is going to be negative infinity. That's when the limit for this for x approach to the infinity 7x cubed minus 2x squared plus 1 equals to the negative.
So infinity minus negative minus infinity is infinity.
Infinity, you can say 0. Because we can't tell which infinity this one, which number, still don't. So we're gonna say, okay, it's still infinity, but the 0, this part is going to be 0. So everything here is going to infinity. This is 0, this is 0 minus 2. Any positive number divided by 2 or by negative number is going to be negative. Then you have infinity. Let's check for this example. We want to find the limit for the cubic root of 2x squared minus 3x squared minus 5. Careful here. The limit for everything here, it's a cubic root. Can I divide both here by x squared? The highest exponent here is x squared. First of all, you can't. Why? Because if you go back to the notes, you're gonna divide. For the first example, you can divide only if there's a limit inside. But there is a rule that says, okay, if you have limit for a radical, you can take the limit inside the radical. So this one is going to be equal the cubic root of the limit of 2x squared minus 3 over 3x squared minus 5. I can say that it's going to be the same result. Now, the limit for everything here under the radical. Now, yes, I can divide by x squared. So it's going to be the cubic root of the limit x approach to the negative infinity. Going to be 2x squared divided by x squared minus 3 divided by x squared. Everything is divided by 3x squared divided by x squared minus 5 divided by x squared. So it's going to be the cubic root of. Let's check. Cancel these, the left is 2. The limit for 3 over x squared is 0. So it's going to be minus 0. Cancel these two x's, it's going to be 3. The limit for constant is constant. Minus the limit for 5 over x squared is going to be 0, so minus 0. So the result is going to be the cubic root of 2 over. That's it, just keep it like this. Okay. It's the limit to the x going to the negative. Let's take the next example. Now, the next example, we have square root of x squared plus 2 divide by 3x minus 6. Let's see. Let's solve this one. Be careful now. Can I divide by the highest exponent of the x with the highest exponent on the bottom? Just x. Be careful here. Because x, if I divide x squared plus 2, divide by x, I can't put the x under the root. Because we have square root here. So let's check here. We already know the square root of x, let's say x squared, is going to be plus or minus x. Okay? Square root for x squared is going to be positive and negative x. We have two results. So now I'm going to look. What about if I divide this is a different form equal to the x squared, square root of x squared? There's a different form to review positive or negative. Think about that. Look. I need a different form for the x square root of x squared. It's going to be equal to this part. You know what I'm
X1/2 conversion. Equal to.
No, I'm not talking about the limit now. I'm talking, I need a different form similar to this one. When you enter the x, the result is going to be positive or negative. If you think about absolute value of x, the absolute value of x, if I plug in negative x, the result is going to be positive. If I plug in positive x, the result is going to be positive. So I have two inputs. My input is negative when that means x less than 0, or the positive when x greater than the same. So negative x and positive x. That means the square root of x squared is pretty much similar to the absolute value. Okay, so instead of dividing by square root of x, and it's going to be a problem here on the bottom part, I'm going to divide by absolute value of x. So I'm going to say this one is similar to the limit when x approaches 0, square root of x squared plus 2 divided by absolute value of x divided by 3x. I'm going to say, okay, divide by x minus 6 divided by x, which is the same thing. I just now it's easier to work on because I already know the absolute value of x is equal to 1. So I can put down now the square root and put it under 1 root. So this one is going to equal the limit of x approach to the infinity is going to be square root of x squared plus 2 and divide by square root of x, and everything is divided by 3x over absolute value of x minus 6. Okay. That's mean this part is going to be equal the limit when x approaches the infinity, going to be everything is x squared plus 2. I can write down like this. Yes or no? Because it's a dynamic and I'm putting this one under the root. And here is a 3x over x is going to the positive infinity minus 6 over x. So now just simplify it more. Is going to be the limit. X approaches the infinity. This is 1. It is square root of 1 minus 2 over x squared over cancel these. So it's going to be 3 minus 6 over x. So if you take in the limit, we already know the limit is goes under the root. And the previous example. So the limit for the constant, so it will be constant. This one is going to be still square root of 1 minus 0 over. The limit for the constant is constant. The limit for 6 over x is going to be 0. So the square root of 1 minus 0 is 1. Square root of 1 is going to be 1. That's mean going to be 1. Okay. Have radical with 2 terms. And minus another term. So first of all, we can distribute the limit, or we can't do the limit for each term, because these 2 terms under the radical and the other term by itself. So in this case, how are we gonna do that? The first step, what I'm going to do, I'm gonna say, okay, this is equal the limit when x approaches to the infinity is the square root of x to the power 4 plus 2 minus x squared over 1. That's mean when I have radical, so I'm going to multiply by the conjugate. I need to cancel the radical. So it's easier for me. So I'm going to say, okay, I'm going to multiply by square root of x to the power 4 plus 2 plus x squared. And everything also here. X to the power 4 plus 2 plus x. Yes. So I multiply the square root by square root going to be the limit. X approaches the infinity. Square root by square root is going to be x to the power 4 plus 2. Right? Without the root. The square root here times x is going to be plus x squared square root of x to the power 4 plus 2. Now negative x times the square root is going to be negative x squared, the square root of x to the power 4 plus 2. Negative x times x going to be negative x to the power. Everything is y divided by square root of x to the power 4 plus 2 plus x squared. Cancel these two. One positive, one negative. And x to the power 4 cancel the negative x. So what's the left? Is the limit when x approaches the infinity. Of the time it's only 2 divided by x to the power 4 plus 2 plus x. Now it's easier to work. Because on the top we have only constant. On the bottom, I need to divide by x to the power of what? Can I divide by x to the power 4? I can't because I have roots here. So in this case, x squared, which is equal square root of x to the power 4. Yes? So I can divide by x squared, which is the same thing, the square root of x4. Because that's mean when I write down here this part and then the square root of x to the power 4 is going to go together. So I can cancel x to the power 4 with x to the power 4. Okay. So in this case, we're going to divide by x squared. That means this one is equal to for x approach to the infinity. 2 divided by x squared. And I can tell 2 divided by x squared is going to be the 0. 0 divided by anything is going to be 0. So I can tell by just dividing by x squared, that's it. The result is going to be 0. Here it's going to be,
It can also be undefined. Well,
it could be, okay. X to the power 4 plus 2 and divide by square root of x to the power 4, which is x squared. And the plus x squared, I can say divide by x squared. So these are the same. X squared, x squared. The top is going to be, the limit for this one is going to be 0. This is 1. Square root of 1 is going to be, let's write it down. X squared. Here is going to be the square root of x to the power 4 plus x to the power 4 plus 2 over x to the power 4. And this one plus this one. That's mean the limit when x approaches to the infinity, this one 0. 1 plus 0 is going to be 1 plus 1, and the result is going to be 0. Okay.